temperature entering the reactor. Notice I don't call this T1 because I don't want this to get confusing. V1 and V2 just mean that if we're looking along the, and it'll make more sense when we open up Excel. When we're looking along it, we're just going to use a little volume and then a little more volume and then a little more volume. We're just going to keep going. Again, I think that much will be clear once we switch into Excel. But T0 is the temperature entering the reactor, and it's 1100 Kelvin in this case. And so again, now I also have this equation for temperature. So the temperature at V1 is equal to the delta H reaction times the conversion at V1. Yeah?
I can't really tell what the decimal is on 342.
There is no decimal.
Okay.
So that would be why you can't see it. Where was I? Okay. Times the conversion at V1 plus the heat capacity of A times the inlet temperature. This temperature is not changing. This is always the inlet temperature. Divided by heat capacity of A. And again, I can write it in that notation. I don't know why. I always write it in the other one. But I can rearrange it so that T naught is out by itself, and you just have delta H divided by Cp times conversion. Any questions? Okay, let's see how easy this is. Should be pretty straightforward. Yeah.
So what you're essentially doing is you're taking x2 is equal to xv1 plus the derivative times the delta v.
Yes. Yeah, no, this is just the left-hand side of the equation. The right-hand side is the same.
What I'm asking is in Excel, are you going to step by small volumes,
Yep.
basically?
Yep, you got it.
Is the way you do it, like you set V1 equal to 0,
Yep.
and V2 goes even higher, 500?
Well, no, V1 will be changing the whole time. But for the first data point, you got to have a boundary condition. And we know the boundary conditions for this problem, right? At 0, the volume is 0, the conversion is 0, the temperature is 1100.
So you change both V values?
Yeah, we're going to, again, it'll make sense once we get it up here, but we're going to start at 0 and some small value, like 1 milliliter. And then we'll go to 1 and 2 milliliters, and then we're going to 2 to 3 milliliters. And the whole time, though, we're going to use these equations in order to solve for what we want. Any other questions? All right, I'm going to kill some of the lights. Why are these organized by columns? What moron? This is supposed to be a school that prides itself in like science and technology and engineering, and they did the light switches by columns. All right, anyways. End rant. I realize this room's like probably 100 years old, but it's still annoying.
Been to the Uninops lab lately?
No, I have not been to Uninops Lab. I went to Uninops Lab on my second interview here, and I have no idea why they set me up with a meeting with Dr. Johns, who's like sitting there in a tank top and shorts, and I'm like seeing this man's chest, his entire chest, and he's like bragging about how this is his office, that he just sits in Uninops all the time, and I'm like, do they want me to come here? I've done the job. You know, so you have 2 visits. The first is an interview. The second, they're like trying to win you over. And then they set me up with a meeting in that context. And I'm like, they might not actually want me to come here. I'm going to tell them no anyway. I mean, I'm going to tell them yes anyway. Okay, so, you know, how we set things up is not that big of a deal. But so, you know, even though that you're moving to Excel, you still want to be paranoid with your units. I'm going to zoom in a little bit. So the volume, I'm putting here liters. The book gives you the volume in decimeters cubed. They're the same. Okay. And then conversion is unitless. Temperature. And then rate constant. And I think that's all that we'll need to put specifically in here. And I think where the rate constant is
1 over time.
Yeah, it should be 1 over time, right? Because it's just a first order reaction. All right, so if we're looking at the equations that we had, we're going to start with a volume of 0. So what's the conversion at 0 volume? 0. What's the temperature at 0 volume? Yeah, so we're going to set this up a little bit differently. I'm not going to put the numbers in directly. I'm going to put all the numbers we care about on the right. So one little rule of thumb this isn't a course on Excel, but one rule of thumb, if you're making an Excel formula, never type a number in. That should be a cell somewhere on your spreadsheet. It's much, much easier. It'll save you time in the long run. All right, so that's in Kelvin, and that's 1100. So that is just equal to that. Okay, and then K, we have this formula. This is, I'm now going to immediately violate my rule of never putting numbers in, because I don't know what these numbers represent, so I'm just going to put them in explicitly. So you have the exponent of 34.34 minus this temperature. No, sorry. Minus 34,222 divided by this temperature. So that's the initial K is about 25. And of course, as we go down, what's going to happen? Conversion is going to increase, temperature is going to decrease, the rate constant will decrease. So the step size which you take can have an impact on your final numerical accuracy. I would just take a small step. You guys all have Excel, you have decent enough computers. You can have this be 20,000 rows long if you wanted to. I'll just put 1 milliliter, and we'll drag this down to, now that's going to be, I think the answer is you end up getting, I don't know. The step size doesn't really matter right now. You can always change it.
Make the step size a cell.
You can make a cell. Let's do that. That's a good point. So dV, and that'll also be in liters. And for now, we'll put 1e -3. And so this is going to be equal to what? The previous one plus the step. Now, one little thing in Excel, hopefully you guys already know this, but if you're going to drag a formula and one of the references isn't changing, you can put $signs. The other thing you can do is hit F4, which will also put $signs. And this just means that the reference to I2 won't change. The reference to A3 will change, but I want it to change. Okay, and now this is the one that is going to be long, right? So before we do that, let's remind ourselves what the formula is without putting it back on the board. But I gave you the left-hand side here. The right-hand side hasn't changed. And the right-hand side includes K, which isn't a big deal. We've already got that on our spreadsheet. CA naught, so we can add that. And what did we say CA naught was? Damn it, where'd my... Here it is. CA naught was 2 divided by 1100 divided by R. And what else do we need? We need epsilon. We did it on the board, but it's just P naught over R divided by T naught. So it's 2 atmospheres divided by 1100 Kelvin and then R, which again I can at least use this one since I made that a formula. If I'm being really thorough, I can make these formulas as well. So this is in liter atmosphere per mole Kelvin. All right, so CA naught was equal to P naught divided by R divided by T. And the units all work out there, so I don't need any unit conversion. What was epsilon? 1, right? And again, we're gonna, that's only true when theta I is equal to 0, but we'll relax that in a second. For now, we're just gonna plug through. And is there anything else that we needed? FA naught is also on the right-hand side of my equation, and that was given 10 moles per minute. Okay, so I didn't rearrange this, but to rearrange it, right, all I have to do is multiply by the change in volume, add the conversion at the previous step. So the change in volume is one of my parameters, dV. But first we'll put in the previous conversion. So it's the previous conversion plus the change in volume, and now times the original right-hand side of the equation, which you have in your notes, which reads K here times CA naught 1 minus the conversion. And notice, anytime I use conversion, I just use the previous one. For all of this stuff, K, temperature, anything, I'm just going to use the previous value. Times T naught, and then that is all divided by FA naught times 1 plus epsilon times the conversion again times the previous temperature. So any questions on where that equation came from?
Yes.
Okay.
Kind of, where did you get that from?
Here's the left-hand side. I've rearranged it so that I'm solving for x at the second volume. So in other words, I've moved over this dv and I've added this to the right-hand side, which is right here.
Oh, gotcha.
All right. And we get some gigantic number, which means we have something. Yeah, CA naught is definitely not correct. I divided by dV instead of the initial temperature. So yeah, it should be, this is what we had on the board too, 2.22 times 10 to the negative 2. And now you get a slightly smaller conversion. Yeah.
Also, the K units for seconds and minutes are, I think there's an issue with seconds and minutes somewhere.
I know what you're talking about. I don't know what units it gave me for K. So I think we might assume. Can I expand what?
Expand the formula.
Yeah. What do you mean?
Click into it.
Oh, you like the colors?
No, in the cell.
I mean, click on the cell. Oh, sorry.